All the beautiful people, ha ha ha. What's going on out there, YouTube? We have this one of those rare occasions when I gotta go back and make a video to correct myself. Happens once in a while. Anyways, some new and improved information has just showed up magically. And if you watch the first video, you're going to be way ahead of the class. All right. Let's see, I got to get my drumstick. I can't perform my educational video without my drumstick. All right. Aswan, Egypt, unfinished obelisk purpose. All right. So what's it all about? Okay, we did the thing yesterday. Is it the obelisk or a needle pointing into the sun's declination and Earth's ice age tilt? Still got the incorrect grammar here, or double words. But anyways, the obelisk is pointing 7 degrees northeast. The sun's azimuth angle on the summer solstice is 64 degrees. All right, remember that. In Aswan, Egypt, currently the unfinished obelisk is pointing 7 degrees. An obvious record indicating the Earth's tilt during the time of the making of the unfinished obelisk, and the obvious ice age tilt of the Earth where glaciers are growing and not melting. Alright, point being a 6-degree change, and the azimuth is enough to send the planet into an ice age. There are 50 to 55 holes. This is the discovery I made. You know, I'm watching the video like you guys because I got to watch this stuff just to see how it comes out. As painful as it may be, I still have to look at it, right? And then I realized, I said, well, what's the angle of those holes that I mistakenly said were drilled recently during our era, which possibly could still be, but pretty amazing discovery, all right? 50 to 55 holes, probably 52, but it's hard to count. Into the obelisk that are at the above mentioned alignment of 64 degrees. So those holes, which I'm going to show you in a few seconds, are actually 64 degrees, okay, on the azimuth. And that's crazy because I was saying it's 64 degrees off, the sun's over here, the the obelisk is pointed at 70 degrees, 6 degrees over. And lo and behold, some beautiful individual had put in 50 some odd holes right on the ground at 64 degrees angle, right? Lining up perfectly with the summer solstice current time. All right. No, that's the northern hemisphere. Sorry for all you people down in the southern hemisphere. We love you, but we're up in the north, so we got to take care of the northerners. All right. It's a great picture here. Like I said earlier in the other video, get the oldest pictures you can, the drawings, the diagrams, sketches. You know, that's where you're gonna, that's the stuff you can actually build an argument off of, a theory off of, a case off of. So anyway, here's the guy right here. He's got the actual shaved part, or the pointy part of the obelisk is actually buried under this crap. And he's still on the square section. Now remember this, he's got the crack right behind him. And those holes right here, okay, 50 some odd holes, 52, I'll just say 52 holes, representing the weeks of the year. 52 holes are right here. And you can see it over here, same place. Again, this picture was taken in 1904. Let's see. I don't know who the heck is in Washington, D.C. Well, it doesn't really matter. It's 1904. Okay, now I'm going to show you the picture where this guy is actually standing. Okay, he's actually standing right on the holes, almost right to the right of it. And this is the crack right behind his legs. And this angle, which I've deduced by doing some work, is actually 64 degrees. All right, on the sun's azimuth. Okay, So 64 degrees. Azimuth. And pretty profound. So that's just like pretty amazing. You know what I mean? In my world, anyways. So here's the makeup composite of mica, of granite rather, mica, quartz, plagioclase, and K feldspar. Here I am overheating up there, and everybody else is freezing. Up there in the Aswan Quarry. Now here's, you can see they just make the holes out right there. Got the crack right here. Guy was standing right here. Obviously he cleaned out a lot of crud out of the way. Again, I'm theorizing this thing was never meant to come out of the pit here, and it was actually instrumentation, you know, just to show us where the sun was actually rising on the summer solstice in the northern hemisphere. Now, after the tilt, somebody still came. They still came because they knew what this thing was actually was built for, and they came in and they put down 52 weeks, and that's the summer solstice. So there was somebody still practicing the sciences back there. They wouldn't. They didn't haul them off and burn them at the stake, or what do they call it? Draw and quarter them, draw them. Yeah, draw and quarter them, and cut them up into quarters and spin them all over the county. But or worse. So somebody was actually smart enough to go ahead and drill these holes. Now, I mean, it's like it's possible that was way back, because we saw the guy that just cleared it off in 1904. Now, here's a crack again, and you can barely see it. You can't really see it that good on that one. But that's a pretty old photo there, well, relatively speaking. Here's an aerial view. Okay. I mean, it's almost like the Albek Stone. The Albek Stone is measuring something else. Just putting an argument out, just a theory out there. That might represent another tilt that the Earth is in. Okay. It has the same kind of features as this thing. It's absolutely enormous, over 1,000 tons. All right, here's the 70 degrees. Here's the 64 that we're talking about. That those little lines are actually pointing right at the 64 degrees. Okay, which is the summer solstice sunrise. And azimuth angle measured clockwise from north on the compass. All right, so you go from the north and you zip it all the way around. The obelisk is looking at 70 degrees, and you back it up 6 degrees, and the sun is rising up 6 degrees further north than where the obelisk was placed into that position when they cut it. Another picture of it here. Here's the holes, and hope you can see the holes here. Can you see the holes? Yeah, you can see the holes. They're right here. I mean, they're pretty accurate, and obviously we lose a hole in the crack here in the cut, so it's kind of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. Now the holes go off the picture the other way, another 20 some odd holes being drilled. You can see more of it down here. So I invite you to go check this stuff out on Google it, check them out, count them, and it's pretty close to 52. But anyways, that all being said, it's directly in line with the summer solstice. Now I'm sure somebody's probably looked at that, maybe, who knows. I haven't heard anything on the internet. I Googled it, but it could be some independent researcher that's got some notes somewhere. You got thousands and thousands and tens of thousands and thousands of people looking at this stuff, doing their own research. So pipe up if you have any information on it. And again, these are the square grooves. I talked about how these were made. They were using some kind of instead of using round dowels and chisels with feathers, they were actually using some square type of devices. Just square dowels, really, instead of round. They were using square. These are round ones. These are actually square here. They're going slant, but these are somewhat tapered, four-sided. They call it chisels, and these are the feathers that's going on the side. You just bang them in, and you split them. It's great. It's got photo here, people, right here. This is how they set them up. They drill, put the feathers in, put the the dowel in, the pin in, and we're able to smash it. Now, this particular cut, you don't really see the striations. It's because it's all got to do with the shadows in the photographs and the actual sunlight. So, but I can see it because I'm standing right here. You can see some of the straight lines where the actual dowels were put in. Now, I'm theorizing instead of using the round dowels, they were actually cutting square holes up here and putting a square wedge in and popping it. And that's why you have a different kind of like a scoop-like type of indentation into the stone. Not like this here. You can see the dark, the light, where these things are breaking. They actually come straight down and break the structure right in half. Now these are those rectangular holes that I took some pictures while I was up there at the quarry. These holes are all over the place, but they're pretty accurate. They're in line, but like I said, you can just get a square edge in there, and you can break a lot more and have a lot more control. All right, over where the stone's going to break. So the round ones, it gets a little, they can go left or right or what have you. I think you get more accuracy carving them out. You can see the rectangular slots up here at the end. There's one right here. Again, the holes drilled are over here, and this is the crack. It was already there when they made it. They know the crack was there. This was meant to be an indication of where the sun was rising at this era, this time when they were quarrying these stones, which is anybody's guess. Thousands of years ago. There's another guy, there's other people, beautiful people. I believe they had water technology back then. There's a lot of indication of high pressure water being used on the Giza Plateau. Again, I go for the older pictures. I look for the older pictures before I make these statements, the older drawings. And to my knowledge, I don't know of any high pressure quarrying going on the Giza Plateau in in this time that we're in right now. And most of the stuff was under sand at the 1800s anyway, so it's pretty evident that this stuff was buried, and when we uncovered it, that's it. Now this is what I'm talking about here. You got these indications of the blocks being harvested to make the pyramid, and on the bedrock where these things were cut out of, you'll see the nozzles, where the high pressure nozzles that were cutting these stones, this limestone. Like right here, I was actually on the Giza Plateau a few weeks ago, and I was looking at these big puncture marks, right, just blasted straight into it. Again, I don't have any records. What I found is nobody's gone here and done any quarrying of stones with high-tech, high-pressure cutting equipment. So that all being said, it looks like these were done when they were building the pyramids. So obviously, high technology. Well, our technology. I don't know if you want to call it high, but high pressure. We're talking like 60 or 100,000 psi. I've worked with this stuff. It's dangerous. It's all compression. Big diesel engines, high pressure, super strong piping, seamless steel. you're at the limitations of the material sciences at these pressures. Very dangerous equipment, but it works. We're using it every day for a multitude of tasks in this industrial age that we live in. So, I don't know, for some reason these didn't come out on the picture yesterday. Maybe they'll come out today. But you can see the equipment. It's hard to tell if it's coming through, but this is just a big piece of steel. But this is the lance with the tubes hooked to it, and it's just slicing right through the rock. It's just effortlessly. It's actually pretty quick. You don't have to replace the blades. It's a lot easier to move around. You can actually do the stuff by hand. Like you can have a guy holding this thing and just cutting it himself if you wanted to. I think, I had a couple questions on the previous video about sandblasting. Yeah, I think there was sandblasting. If you were doing water cutting, which you can obviously see, sandblasting is another methodology. That's like you go to any graveyard on the planet, and they put your name in there, the date, born, dead, whatever, the rest of the family members. It's all, and it's granite stone. It's cut right into the granite with small little pencil sandblasting tool. So that all being said, it's and there's plenty of sand. There's no loss of sand out here. I'll tell you. Although we like to use carbon. Carbon's a great sanding medium for sandblasters. It's strong. It's like it's right up there with diamond. It's very very hard substance. And these are the pock marks that I'm talking about. So if these blocks were here, the next step up, they were coming in, cutting it horizontally, and they just, they'd stop, hold it, whatever, but they would puncture these holes. And anybody been out in the Giza Plateau, you'll be looking at these walls and you go, what is going on here? Like, where are all these big holes? Like, were they shooting, mortars at this thing or what? No, it's actually carved out by water pressure. And now what the hell, we'll put the video on again. Take a chance anyways. Take a few seconds. Yeah, just go out there. You can Google this stuff. You get better pictures, better videos. See this stuff out there. But it really just tell, we know they had some high technology out there. It was, it's just obvious that 70-ton beams, granite beams coming from Aswan, the mirror finishes put together. You can't even put a blade into the.
Quarry equipment provides a safe and incident-free working environment. Precision cutting ensures a cost-effective alternative to blasting.
There you go. A safe alternative to blasting. Yes, indeed. We don't like blasting. Now, I'm being a little sarcastic, but yeah, this you can do this. You can you can use anything. If you want to pound all day and do things. But if you look at the accuracy of the lines in Aswan, where the obelisk is, they're almost perfectly vertical. Same spacing. It's obviously that it was done with precision, cutting down. Now, you're not going to get that kind of precision with a stone ball. Yeah, you're just not going to do it. You got to get down with wedges, pop it out, drill, pop it out, drill, pop it out, carve it out, pop it out. Like I said, diamond technology's been on the planet for a long time, and I'm not sure if we have any diamonds in Egypt, but Egypt is in Africa, and Africa has the largest diamond mine. So, that all being said, like I said, it'd be easy peasy, Japanesey, you pour your, I misspoke, yes, I was saying a Bronze Age, copper. You could have made, primitive copper tools with diamond dust in it, right? Get the copper liquefied. You pour it into a mold. You can sprinkle diamond dust right at the edges of the blade, or have it in the mold already. So the copper, it would be diamond impregnated copper, for blades, drilling tubes, drill bits, what have you, and you could be cutting through, stone granite. Now, obviously, India's got some wild stonework that's an enigma, just like Egypt is. It's just another country where there's just these giant enigmas out of time, out of space time, that just don't fit into the current explanations. So yeah, so it's not, I mean, it's just going back. They know at least three